Alright, so for our problem here, we are asked to graph the triangles with the given vertices and then identify the transformation. So looking at the graphs, we can see that it's a reflection on the y-axis, right? So folded along the y-axis to get from ABC to FED. And now we're supposed to prove that it's, or verify that it's a congruence transformation, meaning this triangle is congruent with that triangle. And we could do it visually for AB. AB is congruent with ED, of course, 2 units. We could also do it with CB and EF, right? Those are both 3 units, so we're going to say that those are equal. But then the hypotenuses of the triangles are going to require the distance formula. So it's FD is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Same thing with AC, and we get square root 13 in both of those cases. So we can say that the triangles are congruent because of SSS, right? Okay. And then what? We have a couple more problems over here. This is a translation, right? So if this here is the pre-image, then we're translating down and to the left, right, to get to the image. This one here is a rotation. It looks like a 90-degree clockwise rotation along the origin. And then for this problem, we're supposed to identify the transformation. So to get from here to here, it appears to be a rotation of 90 degrees clockwise, right? So we're moving that way. And then we need to verify that it's a congruence transformation, meaning we end up with a triangle that's congruent to the original triangle. And so we have to do that because we have to do that with distance formula. So we do AD, we find that it's square root 13, and then we do the distance formula from B to D. Oh, I wrote D, but it should be O, I think. Yeah, it should be O. And we found that that's square root of 13. So AD is congruent to BO, right? And then we're going to DE. We're checking if DE is congruent with BC. So DE turns out to be square root 18, and BC turns out to be square root 18 as well. So those are congruent. And then EA is, by looking at the figure, is 1, 2, 3, 4, 5 units. And then OC is also 1, 2, 3, 4, 5 units. So we could say that they're equal to each other. And thus we could say via side, side, side that the triangles are congruent. And then we have a couple more problems. We have a similar problem here. I'm not going to go through the details, but we use side, side, side here to prove that the triangles are congruent. And then this last problem is Carly wanting flowers on her ceiling, but she wants all the flowers to look exactly the same. So what kind of transformation should she use and why? Well, my answer is that transformation, rotation, and reflection will all produce flowers that appear the same, because they're congruent, right? They're going to be congruent. But if she wants them to be like in the same angle, and also the same, like exactly the same, as it says here in the prompt, then the transformation she would use, this shouldn't be transformation, it should be translation. Then she should be using a translation, because then every flower is going to look exactly the same. If she uses a rotation, then some flowers are going to be looking like that, and other flowers are going to be looking like that. And although they will be the same, they won't have the same angle. And then she doesn't want to use a reflection either, because let's say that the right side of the flower had a leaf, and the left side of the flower did not have a leaf. Then the reflection would make the leaf change sides from the right side to the left side, right? So then the transformation that she would want to use so that the flowers look exactly the same would be translation.